What I do want to do, though, is I just want to cover some of the stuff that we've covered in previous sections, just to start and remind you of the different things, because my guess is you didn't look or think about Algebra 2 at all over the extended weekend. Okay. All right. So then what we are going to do now then is we're going to remember learning target 1, which is I can simplify expressions with rational exponents. So remember, you can get a 2 out of 4 just by typing this in your calculator, but if you want the full credit, you're going to tell me that 36 to the 3/2 power is what? You could, but you can, and it's useful to be able to do that. And then 3 divided by 2. Okay, but that will only get you half credit. That's a 2 out of 4. We want to be able to do better than that. So if I have 36 to the 3/2 power, you just set it on my desk. If I have 36 to the 3/2 power, how can I simplify this? And the 1/2 power, so if I have 36 to the 3/2 power, that's the same as 36 to the 1/2 power to the 3rd power. But what do we know about the 1/2 power? Divide by 2. So this is 18. Now, what do we know about the 1/2 power? It's the same as the square root. So if I had the 1/3 power, it'd be the 3rd root. So this is the same as the square root of 36 to the 3rd power. And what do we know about the square root of 36? It is 6. But I'm taking an even root, so that means it's plus or minus 6. I'm so glad, and you all should be so thankful you have someone so considerate to teach you these things over again, because I knew you would forget about this stuff over again. Thank you. See, she gets at least what I'm trying to get out of you guys. All right, and then 6 to the 3rd power. You can find on your cheat sheet. You find root 6 and go to the 3rd power cube. Six is a root. 2nd power, 3rd power, 216. Folks, you cannot forget, okay, major concept of this whole chapter of understanding that the 1/2 power is the square root. The 1/3 power is the cube root. The 1/4 power is the 4th root. Can't forget about that stuff. Big concept. Do I have any questions about learning target 1 problem? Okay, learning target 2. I can solve problems with nth roots. So if I want to take this problem and I want to solve it, what can I do? 4th root, because that's the main concept. Additionally, is understanding the relationship between 4th powers and 4th roots. If I 4th root something that's being taken to the 4th power, what happens with my 4th root and my 4th power? They cancel out, and I'm left with just x plus 14 is equal to 4th root of 1296. 1296 is here, and its root is 6. Is it 6 or is it plus or minus 6? It is plus or minus because of the root I'm taking is even. And then I minus 14. To get negative 14 plus or minus 6. And so if I want my 2 answers from here, I'm going to have to take my work and say x is equal to negative 14 plus 6. So x is negative 8. And then the other thing I'm going to have to take is x is equal to negative 14 minus 6. So x is negative 20. Do I have any questions about learning target 2? This was from a while ago. Sounds like you have questions. Oh, wow. All right, anything here? All right, just two more quick ones. Again, I'm just kind of giving you a fast recap to the best of my ability. I'm going to make some problems up on the fly. I don't have them memorized or written down somewhere else, just really quick. Learning target 3 is using exponent properties that involve rational exponents. So if I have 625 to the 4th power over 125 to the 4th power, and that whole thing to the 1/2 power. It is quotient because I'm dividing. But what do I know about something when I'm dividing and they each have that 4th power? I can kind of pull that 4th power out. I can undo the power of the quotient property. I can take that 4th power out of each of those. Okay, and so then when I have that, then I can just go 625 divided by 125, which is 5. So now I have 5 to the 4th power to the 1/2 power. 5 to the 4th power is 625. 625 to the 1/2 power is the square root of 625, but I have this problem. If I go to my fantastic chart of squares and roots, my squares only go to 400, and I'm at 625. So what can I do to figure out the square root of 625? If it's not on my table, calculator, 625 to the 1/2 power, 25. All right. Last one before we actually go to the lesson. Learning target 4. Can simplify radical expressions. Okay. Learning target 4 is still a struggle for us, so we're going to be going over this probably to start every class for a while. I cannot have a fraction inside my radical. So maybe the best place for me to go is to radical the top and radical the bottom. But then I realized that I cannot have a radical on the bottom of my fraction. So what do I have to do to the bottom here? Make it a what? I do have to multiply it to something. But the question is, what do I have to multiply it to? The thing, obviously. We need the bottom to be, no, we're not there. We need the bottom. Yeah, it is the thing where we multiply the thing. Yes. Okay. Specifically, okay, and this is why I'm going over it, and I'll continue to go over it. I need the bottom number to be a perfect 5th power. If this is not a conjugate one, because I don't have a plus or minus. I need this bottom to be a perfect 5th power, because if it's a perfect 5th power, I can just take the 5th root of it. So I'm going to look at my perfect 5th powers, and I'm going to say, is 125 one of them? No. So I need to try to multiply 125 up to one of these perfect 5th powers. So I'm going to look at the first perfect 5th power bigger than 125, which is 243. So I'm going to take 243, I'm going to divide it by 125 and realize that's decimal. Then I'm going to take 124 or 1024, I'm going to divide it by 125. No, 3125 divided by 125, and I do get a nice neat whole number. So I can make 125 a perfect 5th power by multiplying it by 25 to get 3125. That's exactly what you were saying. Does anybody have any questions about how I knew the 5th root of 25 over the 5th root of 25? All right. Hopefully, if you're too shy to ask, you'll see some reasons why. 6 times 25 on the top, 5th root of 150. On the bottom, 125 times 25. 3125. Isn't that just neat? Because I think 3125 is a perfect 5th power. Get out. No way. Look at that. What's 3125's root? 5. So then now I have not changed the value of the expression, but I have simplified it because the bottom does not have a radical. This and this are the same thing. Simplified, not simplified. Lovely. All right. Previously in math class, you know what? That's what we should do is we should have somebody. You ever see shows like Game of Thrones or The Sopranos, where they have that at the beginning of like previously on Game of Thrones, and then they do a whole intro. We should have one of you do that for every math class. What? Previously in algebra 2. You guys don't think that's a good idea? That's a good idea. Yeah, me too. I think she'd do a great job. Hey, here's the thing. You guys say I hate fun, but I think I actually love fun. And you guys just don't know what fun is. Thank you. Oh, okay. All right. It makes me happy. That's all that matters. All right, 6-4. Let's finish this section. Okay, remember in 6-4, we have 2 learning targets, identifying extraneous solutions. That's a 1-point learning target. You either can or cannot. Learning target 5 is graphing. Okay, learning target 6, solving equations that contain radical and rational exponents. Last time, we only did radical. Today, we're going to finish radical equations, and then we'll branch into rational exponents. All right? Remember, you want to get the radical isolated. When you're able to get the radical isolated, they're not overly difficult to undo. I can undo square roots with squaring, and I can undo cube roots with cubing. That's kind of the general concept. So when I look at an example like 5, I know that I have square roots and I can undo square roots with squaring. But the problem is I need to get the radical by itself. So don't write this down. My guess is some of you are going to tell me I can get the radical by itself by subtracting 1, okay? And we can try that. If I do that, then I get the square root of x plus 2 is equal to the square root of 3 minus x minus 1. Well, then, you know what? I want to plus 1 so I can get this radical by itself. And then I'm just right back to where I started, okay? So this is an issue with this problem, is I'm not able to just use addition or subtraction to undo this minus 1 or this plus 1. So what we do have to do is we're going to ultimately have to undo each of those square roots one at a time. So how can I undo this square root? Because this is my additions on this side. So how can I undo this square root? Square it. I would not write very big. So I'm going to square each side here. Notice how I'm writing this. When you square sides of equations, you're squaring the entire side. What happens on the right-hand side? It cancels and I'm left with? Nope, on the right side. I haven't talked about the left side yet. 3 minus x. Okay, now on this side here, it's a bit more complicated. Technically, we have a little binomial here. And this brings up a good question. Do you guys understand what it means to square? Multiply by itself, okay? So when I multiply by itself, they just undo each other. So when I square the square root of x plus 2 and then plus 1, that means I have to take the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. So I actually have to multiply this like it's a binomial. So I'm gonna start multiplying the parts together that I think are not overly difficult, such as 1 times 1. Or 1 times the square root of x plus 2 is positive 1 square roots of x plus 2. And you may have noticed that that same thing's going to happen here. 1 square root of x plus 2. Now what happens here? The square root of x plus 2 times the square root of x plus 2. So if I take 5 times 5, that's the same as 5 squared, right? Do we agree with that? So that means if I take the square root of x plus 2 and I multiply it by the square root of x plus 2, theoretically, that means that's the square root of x plus 2 squared. And what do we know about this? To what? When I multiply by itself, that's what squaring is. So what is the square root of x plus 2 times the square root of x plus 2? Okay. Do I have any questions about that? Okay. So the left-hand side is now x plus 2. Actually, can I write x plus 3? Because I know this one is going to combine with that too. Does that confuse anybody too much? But what about here? 1 square root of x plus 2 plus 1 square root of x plus 2. There's 2 square roots of x plus 2. And that is equal to what? So I squared my problem and I got rid of a radical, but the issue is I'm left with another radical. So what can I do now? Get this radical by itself. Because if I get this radical by itself, what can I do? If I can get this radical by itself, what can I do to undo that radical? Square it. So I'm going to get this radical by itself. I'm going to minus x minus 3. I'm putting on a clinic with nice, neat writing, by the way. I don't know if you guys have noticed this. It looks good so far. What do I have to do to get this radical by itself yet? Because I still have this 2 wandering out here. Divide by 2. There's that one rogue algebra tile in the middle of the screen. I got. What do I do now? How can I, what can I do? Square it, because that's the inverse operation of square rooting. They undo each other. So what's left over on the left-hand side if I square? X plus 2. What about negative 1x all to the second power? Not going to be x. Because that would be just x to the first power. It would be just regular positive x squared. And I know it's positive because squaring is multiplying by itself. Negative 1 times negative 1 is positive 1. So now I have to look at this and I have to ask myself, how do I solve a problem like this? There's two options: set equal to 0 and factor, or get the x by itself. Which option do I have to use here? I do have to set it equal to 0 and factor. How do I know? What's a big giveaway? Yeah, I have two terms of variables here. Specifically, I have a variable of a higher degree. So I'm going to set this equal to 0. And I know that you guys have all been waiting for this moment. It's been 5 days since I've had Algebra 2. That means it's been 5 days since we have referred to the greatest document in the history of mankind. This flow chart here will demonstrate to you the method you have to use to factor this. Is there a greatest common factor? No. How many terms are there? 3. That means I need to find A, B, and C value. Is my A value 1? Yes. So I'm looking for numbers that multiply to my C value, add to my B value. What numbers do multiply to my C value and add to my B value? -2, +1. Since they are -2 and +1, my factors will now be x minus 2, x plus 1. Just now that I have my factors, what do I do with them? I set them equal to 0. Does anybody remember why I set them equal to 0? It is how you solve. I have a number times a second number, and the result is 0. That means this is 0, the first number is 0, or the second number is 0. Zero product property was what I was hoping for, but you know, it's whatever. And I plus 2. Now, learning target 6 says I can solve equations that involve radicals and rational exponents. Okay. So this is a 4-point learning target. 1 second. Okay. This is a 4-point learning target. Okay. But there's a 5th point to it, which is learning target 7, which is I can identify answers that are extraneous or imposter solutions. Anybody remember the 2 different ways we can do that? How do I identify an extraneous solution? I can plug x into the original equation. So I can take the top here and I can go the square root of 2 plus 2 plus 1, and I get 3. I can also take the square root of 3 minus 2 and get 3. Are those the same numbers? What does that tell me about my solution of x is equal to 2? If I plug it in and I don't get the same answer. It is fake. It is an extraneous extra answer. You're going to communicate that to me by putting ext period. But then you still need to check -1. So I'm doing the bottom one. I'm doing the right-hand side first. Square root of 3 minus -1, which would be the square root of 4, which is 2. And then you do the same thing here. -1 plus 2, and then plus 1. And I get the same answer. So what does that tell you? Is x equal to -1 an extraneous solution? If I plug it in, I get the same number on both sides. No, it's the real deal. All right, we have a visitor real quick to talk about Alex testing, and then I'm going to let you try E. All right, this is what you're doing right now. You're going to work on E on your own or with a partner. Okay, and I am going to start the problem. I'll get a little ways into it, and then I'll unfreeze the screen so you can kind of see how you're doing as you go. Hey, I understand that you guys are really excited about problem E. Okay. I get the excitement. I get that you're jazzed about it, but you know. Yeah, what's the answer? It's weird that you got 2 answers. What? Oh. So you get an extraneous answer? It's my first day. Let me tell you, that was something else. I'm going to freeze my screen just so you can see a little bit of it. So check your progress midway through here if you're unsure yourself. one of those. Oh yeah. You did? Yeah. Okay. I'm gonna let you. Okay, so how come this one I only have one answer? I don't have to set it equal to 0 as part of it. Oh, because higher power thing. Yeah. When I square it twice, I end up just reducing it down to a linear equation, which my screen is froze. So you just end up squaring it down to a linear equation. I never end up squaring a variable. Therefore, I never get an x squared or an x to the third or an x to the fourth. So when I reduce it down to these problems, I reduce it down to x to the first power. My highest degree is 1. I'm going to get one answer. Yeah, but that's why. All right. Is there anything else I can elaborate upon this? I like these problems because they're, you know, you told me that you got 3 and then extraneous answer. There's no extraneous answer. All right, so here's the thing about these problems. These are really good problems because they really test your knowledge of everything else we've been doing. Realistically, when it comes to the test, your problems are more like 4 letter D on the previous page. But if you can do these problems, you're gonna have no problem with those other ones, okay? All right, let's do 6. I am going to go on a giant tangent in the middle of these problems, so just prepare yourself, okay? So we've come to the end of solving equations with radical symbols. Okay, that's learning target 6. There's a second part of it, is ones that have rational exponents. So for the most part, we're just done with the radicals. We kind of moved past what I consider the toughest type of problem. Okay. Now in 6, much like when you want to get the radical by itself, on these problems, you want to isolate what has the exponent. So I have 2x to the 3/4 power. So that means I want to get this thing here all by itself. I want to isolate that, whatever has that exponent. This one I can do -2. This 2 is not having that exponent, so I need a -2 right off the bat. All right. I'm really going to stretch your knowledge here. I'm excited for it. What do we know? And you do not have to write this all down because I'm going to write on a note card here. Okay. So what I'm about to talk about, you don't have to write down. You just have to pay attention and try to understand. What does a 3/4 power mean? To the 3rd power. Okay. Do we Okay, we can. We could definitely solve the problem from here because I could do what to undo this cube root or this cube. So now I could cube root this whole thing. I could cube root this whole thing. Okay, and what happens with my cube and cube root? They cancel. So now I'm left with the fourth root of 2x is equal to 2. And then what would I do? How do I undo this fourth root? No. Oh. And then I get 2x is equal to 16. And that means, okay. Is that everybody follows that? Okay. I can do all of this in one step. I mean, you can do all this work. If this makes sense to you, that's fine. Do that. But I know that the 3/4 power is the fourth root cubed. And then I'm cube rooting and then fourth powering. I can do that all in one step. How can I cube root and fourth power all in one step instead of having to split this up and do every single little step? Because I know the 3/4 power is fourth root to the third 4/3 power. I know that at some point to solve this problem, I have to cube root and fourth power. Cube rooting and then fourth power is the 4/3 exponent. For the same reason that fourth root to the third power is the 3/4 exponent. So if I want to undo the 3/4 exponent, what exponent am I going to use? 4/3. If I have the 7/8 exponent, how am I going to undo the 7/8 exponent? 8/7. You guys are geniuses. I didn't have to do anything there. So if I want to undo this exponent, I can undo it with its reciprocal. So the thing that's nice is if you understand the 3/4 power, understanding that this reciprocal is necessary, hopefully is clicking. All right. What happens with 3/4 power and 4/3 power? Okay. 8 to the 4/3 power. This is a time where it's acceptable just to put it into your calculator. Okay. Now, you can just use your calculator for this, or if you really wanted to, you can take the cube root of 8, which is 2, and then take 2 to the 4th power, which is 16. We actually did exactly that, right? We took the cube root of 8 to get to 2, and then we took 2 to the 4th power to get 16. And then I solve by dividing by 2. It's still possible to get extraneous answers. So I need to check my work. I'm going to plug in 8 in for 2. 2 times 8 to the 3/4 power plus 2. 10. So it works. Questions about 6? Or are we good? I actually think these ones are easier than the ones that we just did. Okay, do I have to do anything to get this exponent or this 3x by itself? Okay, so I just have to undo the 1/3 power. How do I undo the 1/3 power? 3/1 power. Okay. It's not basic, it is literally cubing. And this makes sense because the 1/3 power is actually the cube root. And how do you undo cube roots? Cubing. Because it's making sense. But you get what I'm saying, right? The 1/3 power is the cube root. How do you undo cubing? Or cube rooting, cubing? I think that's a sandwich. A Cuban? Also a country? Cuba? Oh. this into the calculator. I did it in my head because I know what the cube root is. Okay. Or no. Yeah, I think you have a great career as one. And then you can check your work by plugging it into the calculator. Then box it in and just cross your fingers that it's a real answer. Okay, one more and we're done. I actually think the rational exponent ones are the easier to solve than the radical ones. Although the radical ones you can always change into a rational exponent if you really want to, right? Because if you have a square root, you can just change that to the 1/2 power. And actually, that's kind of what we have here. Look at that transition. Flawless. I don't need the sarcastic under the comment. All right. So in this particular problem, I have the 1/2 power. The 1/2 power is the same as what? Square root. And how am I going to undo square rooting? Squaring the second power. I did this in the other class and they did not like it. I put brackets instead of parentheses just because like it just helps me see it visually. It's the same as parentheses. It's no different. Oh, it's like the same thing. It just threw them off. I know. You know what? Sometimes I just want to make your life more complicated, okay? It's the same thing. Parentheses and those brackets are the same thing. So you're in my answer key, you're going to see a lot of brackets because I used those in the past. And for whatever reason, you guys get so fixated on it, I just quit doing them and start parentheses everywhere. What happens with the 1/2 exponent and the second exponent? They cancel because they're reciprocals. Then I get my answer like this, and I ask myself, how do I solve something like this? I've set it equals to 0 because my exponent on this variable is higher than 1. I have an x squared, an x to the third, etc. And hypothetically, you get to this point and you're like, I know that this needs to be factored, but I don't know what method to use. Use your resources. I never know. Use your flow chart. Okay, you have to use your flow chart. Okay. Awesome. That's great. All right. So I'm going to go through every single step of factoring this because in the other class we had some issues about finding the numbers that multiply to C and add to B. Okay. So you're going to follow the flow chart. You can take the greatest common factor. You're going to see that there's 3 terms and you're going to identify your A, B, and C value. Okay. So I just some people needed some more instruction on how to find those combination of numbers. I know that the combination of numbers needs to multiply to -30 and add to -1. And some people have enough of those facts just memorized in their head that they understand what that combination it is. I'm going to go through if you don't know those kind, like if you can look at, like for me, I can just look at this and I know immediately what it is. Okay. Some people are also in that boat. If you can't look at this and immediately know what the factors are, this is what I think you should do. All right, 30. And you're going to start asking yourself, what are the whole number combinations that multiply to 30? The first combination will always be 1 and the number itself. So 1 and 30. 1 and 30 can get me to 2 combinations of numbers. It can get me to positive and negative 31, 1 plus 30, and positive and negative 29, 30 minus 1. Neither one of those is 1. Then I'm going to go to the next one, 2 and 15. Check my calculator, 30 divided by 2 is 15. These can get me to 17 and 13. Neither of those numbers are my combination. So I'm going to go 30 divided by 3, get 10. 3 and 10 will give me to 13 and 7. None of those combinations are it. So I divide it by 4, get a decimal, divided by 5, and I get 6. 5 and 6 can give me to 11 and 1, so I know that this is my combination. I'm also out of combinations because after I divide by 5, what's the next number I would divide by? 6, and now I've just repeated myself. Okay, I know it's 5 and 6. It's a matter of what's positive and what's negative. I'm multiplying to a negative, so one of these numbers needs to be negative. -6, you can guess and check at this point. -6 plus 5 is -1. That's exactly what I want. That's what I had. You guys need to pay attention. Obviously, I already had that. I think you guys are smarter than me also. And then once I have my factors, I set them equal to 0. Okay. We talked about plugging it into the equation and getting your answer. There is another way. If you remember, we can look at the graphs of the left side and the right side. Okay, so I can plug in the left side of the equation in my graph. Y equals, clear out this, and then clear out this, and I can go x plus 30 to the 1/2 power. And then the other side, I can just put x. Okay, so right here is my line of x plus 30, the square root, and then I have my straight line of just x. So of my two answers, I know I'm looking at -5 and +6. Which one of those two? -5 is somewhere over here. +6 is somewhere over here. Which one has to be the answer? 6. That's the only one that's realistically is where they cross. So that's real, and this is an imposter.